I want to talk about Cobbs Creek Restoration. It's a project in the city of Philadelphia with the Philadelphia Water Department. And it's a project Dewberry has been working on. Well, we started, I guess, about 2 years ago in 2012. It involves, back to no, the other one. Yeah, there you go. It involves the floodplain wetlands and green stormwater infrastructure, as well as stream restoration and improvements to the gray infrastructure, the combined sewer outfalls in the system that exists along Cobbs Creek within this project study area. And some of the folks assisting on the project, obviously the project is with the City of Philadelphia and the Water Department, but because the project is located within Cobbs Creek Park, located between Market Street at the north end and Baltimore Avenue on the south end, or just south of Baltimore Avenue. It's within that Fairmount Park system, Cobbs Creek Park. So we're working with the Philadelphia Parks and Recreation Department, and they're a key player in this. They own the land, so to speak, and they're a very interested property owner, and so we'll get into some of the discussion on that as well. And then the other firms assisting, Hunt Engineers, Pannoni and Rodriguez Consultants. The project, in terms of an overview, it's really to address the combined sewer overflow impacts. The City of Philadelphia has a large percentage, I think it's probably 60% of the city is serviced or is within combined sewer overflow areas. There are MS4 areas within the city, but this is a CSO area. And you can see really from the amount of pink or impervious area, developed area, and this is the study area, Market Street on the north end and Baltimore Avenue, and in the middle is Marshall Avenue, and the SEPTA rail crossing down at the lower limit. And the City of Philadelphia is on the east side, and Delaware County, Upper Darby Township is on the west side, so Cobbs Creek is the county line between Delaware County and the City of Philadelphia, and a series of private properties abut the stream on the west side. And again, so we've got the city and Cobbs Creek Park, Parks and Recreation Department that owns a tremendous amount of the land, but portions of it are still privately held.
Where are the outfalls of the actual?
The outfalls, there's an outfall just north of Market Street, just south of Market Street, and just south of Marshall Road. And then another outfall right about in the bend here. This is Cobbs Creek Parkway, 63rd Street, and then 61st Street here, and then Baltimore Avenue. And there's another small outfall at that location as well. So there's a total of 5 combined sewer outfalls in the project study area, as well as outfalls in the Delaware County side. Upper Darby Township and Delaware County have outfalls on that side as well. And so there's parallel interceptor sewer that runs along Cobbs Creek on both sides for the most part. And then the Delaware County side crosses over at the cemetery at this location, crosses over and is picked up by the city's combined system at that point.
All the inputs from, I'm trying to understand your problem. The problem was that you had impacts from these combined sewer overflows, but you're not doing changes to those pipes or the amount of material that's coming in from them. So you're dealing with the impacts in the creek from them.
It's a combination. We're dealing with impacts in the stream. We're in essence, we're looking to reduce the stormwater that's getting into those combined sewers through green stormwater infrastructure. So we've got 17 locations where we're doing accommodation, rain gardens, subsurface infiltration, curb bump outs, curb extensions, a number of green stormwater infrastructure facilities along Cobbs Creek Parkway. There are several that are street side behind the curb, so to speak, and underneath the access way. It's a paved asphalt walkway, as well as in a number in the park itself, where we're able to get the water out into some rain garden systems and deal with the additional runoff in those areas, as well as in applying fixes to the eroded outfalls, the combined sewer outfalls, and the channel itself. It's an incised channel, 20 to 30 feet wide, and so we've got stream restoration that's involved. There's 2 miles of stream restoration involved in the project. Currently, we're negotiating or looking to get access across private property on the Delaware County side. And we're also looking to create stormwater wetlands. There are several locations where there are discharges coming down the hillside. We're looking at step pool stormwater systems, the regenerative approach to safely convey those discharges down those slopes and discharge into stormwater wetland systems. Where we have the potential, we want to look to recreate that connection between the floodplain and the stream by either lowering the stream banks or cutting notches in the banks to be able to get the flow out into those areas and create these floodplain wetland systems that'll provide additional treatment to the stream flow itself. And in addition, we're looking at developing trails and improving the pedestrian facilities that currently exist, providing interpretive trails that provide information on the stream restoration, on the green stormwater infrastructure. These are all concepts that are built into the process to be able to bring the public into this and really bring this stream back to the public. It's an underutilized area. It's a discharge area. There are some elements, some issues in the park, and it's a matter of restoring the facility and returning it to what it had been previously in a prior time. And also, it's the Cobbs Creek Community Environmental Education Center is located in this area right here. And so it makes it a great opportunity. It's centrally located. It makes a great opportunity for a classroom and to bring the younger folks in and provide that educational component and get their feet wet and get involved in the project. And they're already doing some things, and so there'll be opportunities as well, and do it in a sustainable manner. I mean, that's typically the approach. So. Now here you can see, again, we're looking at a watershed approach, and our process in looking at this project and determining what the appropriate fixes are. You really need to take a step back in time and determine what has happened to provide those alterations, get a full understanding of that before you can begin to apply the fixes. And that's something that I do regardless. You know, whether you're doing a small rain garden or a large stream restoration, you really need to go back and particularly in these urban areas where there's been a tremendous amount of alteration, because again, you need to fully understand why what has changed. If you're going to be trying to infiltrate within a rain garden, you need to understand: are you going to be infiltrating into bedrock because the ground was up here and it was lowered at some point in time, or has that all been filled? So what's the expectation in terms of the infiltration rates, and what you can do where you can do it based on some of those constraints, as well as the historical and archaeologic issues that you deal with. So that's another reason you need to be, you've got to get permits for this, so you want to know where some of those concerns might be that would take additional investigations and studies that the water department may not want to deal with. They want to fund the project, and so again, identify your opportunities and constraints from that information, and as well as the infrastructure improvements. Identify and get familiar with the infrastructure, the system, as well as the park, how they maintain and what their process is for maintaining, and the water department as well. that's been a bit of a learning curve for us. There's certain structures they will maintain, and other structures they won't maintain. So don't include the ones that they don't maintain in your design, because it will it creates future problems. So yeah, that's again, it's yeah, there was an earlier discussion this morning, you know, about being stuck in the 60s with some of the codes and regulations and so forth, and that's some of what's happening in this case as well. But again, looking back historically to get an idea of what has happened out there, you've got a 2005 image here that shows a tremendous amount of development. And here, the 1890 to 1910 USGS map that indicates where the tributaries had been previously. This is pre-development. So again, you can see these tributary locations, and then you look at the current situation, and even though we're showing where those tributary locations are, that there are no streams at those locations. Currently, what has replaced those streams or those tributary locations are combined sewer outfalls. And that's historically the way City of Philadelphia, many of the major metropolitan areas, New York City, pretty much any of the large older municipalities or large metropolitan areas were developed in that manner. You got to go back in time, if you know. Back in the day, they would, you know, take the waste material, throw it out into the street, or throw it into the back, had outhouses, whatever, and it was a sanitation issue. So you developed a sewer system that would that would treat that system. So you take the low points, which was the stream channels, and they were already fouled anyway by that point, and so those became the areas where the construction took place for those combined sewer discharges. And you
What's the westernmost North Street, North-South Street there? Is that around 30th Street or a little further?
This is 63rd Street is Cobbs Creek Parkway.
Further in where it starts going from City Grid to on the historic map.
Yeah.
Where do the major north-south streets stop on the 1910 map?
The square, this Market Square is about right in this, at the edge. The right-hand edge is about Market Square there, so it kind of.
That's the Schuylkill, not the Delaware.
That's correct.
Okay.
This is the school. Yeah, I'm sorry. I should have oriented you. The Delaware is down below here, and this Schuylkill coming down, and the growth just generally expanded west outside of the city, and most of the development that ultimately took place in this portion of the watershed occurred in the 1910, 1920 era, after, you know, World War I time frame. It's kind of interesting when you look at these major metropolitan areas, the growth, there's a tremendous amount of growth after every one of the world wars, and expansion that goes along with that, and that's so. And again, just looking at the geology of these areas, this is all underlain by Wissahickon schist. Wissahickon schist is a metamorphosed material that weathers down. It's a rock that has been compressed and ultimately then weathers, and it's termed rock flour in a lot of cases. So it's deeply weathered, and when I say deeply weathered, it can be 20, 30 feet deeply weathered, or it can be 8, 9 feet. But in some cases, I've been involved in highway construction projects where it's weathered as much as 90 feet, and you're trying to put a structure on that, and it gets interesting. But anyway, so we can. And here again, you can see the process of development, the historic streams that existed. This is the Schuylkill River here.
That's the Delaware.
Oh, you're right. Yeah, here's the Schuylkill at this location, and Cobbs Creek is over in the extreme left-hand side here. So you've got the Delaware and the Schuylkill in this location. But again, historically the stream patterns, and then currently the combined sewer discharges and outfalls. And you can see how that process developed, taking of those streams and creating those combined sewer culvert arches, or put a form in there and lay the bricks and create and concrete the bottom or brick the bottom. And these discharges would work their way down through, and then when they hit the edge of the stream, there's a parallel interceptor. The parallel interceptor is another sewer line, or sewer lines that run on either side of the stream. And under low flow conditions, the material out of those major outfalls, the combined sewer outfalls, drops into those smaller parallel interceptors and on its way to the sewage treatment plant. What happens under major storm events is you've got the inlets feeding into the combined sewer system, and you've also got the sewer system feeding into that combined system. It overloads the parallel interceptors, and at that point then it backs up in the parallel interceptors and discharges to Cobbs Creek at each one of the 5 combined sewer outfalls. So this was the process that was used in order to develop these areas. Going back historically, you see, and again, what made this possible is that was a hick and schist material. It's a weathered material. You see pictures of them building brick sewer manholes 20 feet up in the air. What's that? Yeah, well, you take and you shave off the high spots because you could readily excavate this material by hand. You put it in a dump cart, and they paid a nickel per single axle wagon cart, horse pulled wagon cart. They gave the fella a nickel, and he might have gotten several loads a day, but anyway, you would bring that and they would fill around the manholes, and that created the level area and shaved off the high spots. And again, that was all by design and by city plan. A plan was developed, and the area developed accordingly, and the sewer and water system to support that infrastructure. And again, that's how a lot of the major metropolitan areas developed. And here you can see Cobbs Creek Parkway at this location. Cobbs Creek Park, this is a 1937 aerial photo. And then you'll see a little inset down here in 1880. And it's a little difficult to see this, but there are several mills located along this portion of the stream. And just upstream from Marshall Road was another mill, was a primary mill dam. And again, you look back geology, at this location where there's a diabase intrusion. So you've got this resistant diabase or granitic bedrock that doesn't weather down like the surrounding material. And so that's created a little nick point in the stream channel, and that's one of the controls on this stream channel. So when we're looking at stream restoration, we need to understand that, because that plays into the restoration approach that we would use in those areas. But again, historically, that's why they put the mill dam there, because it was a convenient place to be able to back up the water, and there was already a place to physically to support that. So again, looking at the mills, and historically there were probably on order of 5 or 6 within the project study area, and so a tremendous amount of diversion of flows. Small streams were diverted as well, and this is a mill race coming down from Naylor's Run. So Naylor's Run was pretty much dammed off up at this location, and then a mill dam and complex of mills in this location. This is right behind the Cobbs Creek Community Environmental Education Center, midway in the project. Fernwood, that was a nice little spring discharge, small perennial discharge stream, and so forth. That's all been filled in with the cemetery waste, but anyway, so that doesn't exist anymore. But anyway, we go back and we look historically at what's happened out there. You can see traces of rail grading, rail siding. There's a lumber yard in this location and the rail sidings, and we see some walls along the stream channel. There's a retaining wall constructed out there, and we go back even further in some of the city maps, and we find that the channel was actually diverted in this location. It originally worked up through this area across Market Street, but before before some of that construction on Market Street, replacement of the current culvert that's out there. You know, we see where there was a major diversion there. And how did we find that? Well, there's an agreement between Delaware County and the city of Philadelphia to move the county line or move the city line. So the surveys identify that. So again, you know, pulling this information together to get a feel for what's the appropriate fix. We are going to be shifting that channel back because it's created some issues in that particular location. So we'll take advantage of that. And again, you see the park. The park and its condition at that point. There's a well-maintained number of sycamore trees along Cobbs Creek Parkway. A few of those still exist. And again, what's the appropriate fix? Now here you can see this is a copy of the city plan, and there were elevations that were identified at each intersection, each of the four corners of the intersection. Those were the grading points those were the elevations that were identified when the city was being planned, when the streets were being planned. Those were the target points to build the streets to. And again, everything worked off of those street elevations and the sewer and manholes. All that was constructed so that it worked according to those elevations. And those are carried through into our current plans, and everything ties back into those city elevations. So what we did is we took this map this is an 18, does it have the date on it? 93, yeah, okay. There it is in the lower left-hand corner. There's several of these at different times in the late 1800s, and anyway, this is in 1893, and it shows the contours that existed prior to the construction to the city plan. And again, the reason we utilized this, these are our proposed rain gardens, green stormwater infrastructure. We have an infiltration, subsurface infiltration storage trench at this location. Curb extensions are further down. Anyway, these are all subsurface infiltration storage locations along Cobbs Creek Parkway. And then a small rain garden at this location, another rain garden here, and then a small rain garden at this location within the current intersection of Marshall Road and Cobbs Creek Parkway. Then this is Marshall Road location back in 1893. Marshall Road currently comes through this area and swings around. Right over in this area here, ties back in over here. So that S curve in Marshall Road runs right through here, and these are the two basins on either side of that Marshall Road. So again, we take our current plan, the contour elevations, lay that in digitally, and then that way we're able to get an idea. Okay, what has changed out there terrain-wise? Are we expecting that this basin is going to be on fill or in cut, or just what? And so in this case, it's pretty much at grade. It hasn't changed significantly. It was about a 2-foot difference. Some locations, Market Street, there's areas where there's probably about 8-9 feet of fill that were placed. And when we went out and did our backhoe test pits, we were able to confirm that and verify and just what the expectation would happen to be. And again, here in this location, these subsurface systems, you can pretty much see the higher ground here. This was lowered in order. This whole area was lowered, and then the other areas in this location here, that was all placed on fill. So again, it also gives you the drainage patterns. If you're going to run into a water table or poorly drained soils, you would expect those to occur where you see those historic drainage patterns. So again, it's going back and looking to get a full understanding. And the model that we're using, really from a restoration standpoint, is really this is out of New York City's high performance infrastructure guidelines. It just, when I saw this cross section, it's very close to what what you would see out there if you were facing south on Cobbs Creek Parkway. You've got the developed area and the potential for green roofs, blue roofs within the city. You've got opportunities on the east side of Cobbs Creek Parkway for various tree trenches, bioretention type systems that work behind the curb. And again, bioretention systems and median. You've got a combined sewer system here, and then the transportation and the park located on the west side of Cobbs Creek Parkway. It really is a nice cross section that just, and again, the opportunities that exist, and that's really what we looked at conceptually, and the approach we're looking at is to try to disconnect that impervious cover and get it out of the combined sewer system. And use the green stormwater infrastructure to intercept that runoff and infiltrate where possible. Where you can't infiltrate, under drains are incorporated into these systems. The subsurface storage systems have under drains in them so that they'll store the runoff for a period of time and then release it slowly. They act like a detention basin, and that's so at least they will hold that water until the peak discharge passes, and then release that slowly into the combined sewer system. So it's not a volume control, but it's a rate control that at least keeps that discharge out of the combined sewer. And again, then the hillside working down into Cobbs Creek itself. Opportunities for riparian restoration along on those areas along Cobbs Creek, and then the green stormwater infrastructure in the level areas just to the west of Cobbs Creek Parkway. And again, some of the design considerations, and I've talked about some of these previously, the diabase and the metamorphosed limestone or the schistose soils. Again, opportunities and constraints. The diabase being an area where they're from a stream restoration standpoint, the diabase is problematic. It's probably one of the more difficult areas to restore because of it's just a narrow point, and the fact that it's backing up the discharges. We get some tremendous velocities and shear stress through those areas. So we're looking at these micaceous silts and sands, and Chester Manor Glen Elg soils, and they infiltrate well. Bedrock is deep when you look at the soil survey, and that's the case. We just finished our infiltration testing, and we've got some pretty decent results, anywhere from 2 to 6 inches per hour, and almost to the point of a little too fast. But and the water department uses 1/4 inch per hour as the minimum infiltration rate. That's the adjusted rate. So right. We did in some of the subsurface storage systems. We did see low infiltration rates, and by policy now, the water department uses the under drains in all of their systems. The larger rain gardens include subsurface storage systems and under drains. In the event that they should happen to clog, it provides a relief valve because it's cheaper to put them in the very beginning than it is to go back in and dig them up and try to restore these systems later. So it's just an economics, and you need that insurance. So we've got alluvial soils down along the stream, legacy sediments because of the mill dams. Some nuisance, tremendous amount of nuisance species along the stream, as is typical in I think anywhere you go in southeastern Pennsylvania, or I don't know, it's not even southeastern Pennsylvania. Any place that's been altered, we have a tremendous amount, and the floodplains carry the seed material down, and so that's one of the primary issues in the wetland areas and the riparian restoration areas. And a large number of trees within the park itself, and we needed to protect those and avoid those. The trees provide a tremendous amount of stormwater uptake, and so to preserve those is really key in anything you do relative to green stormwater infrastructure. Try to avoid them because I saw one of the statistics is 4,000 gallons per year in evapotranspiration, average large tree. So you add that up within a wooded area, I mean, and that's why wooded areas are so stable. And it's because you've got the trees and the evapotranspiration pulling that water, that soil moisture out and evapotranspiring it. So. Then, of course, the access and right-of-way issues. Now here you can see this is the area. This is the granitic diabase rock that's located just downstream of Marshall Road, and you see the polished, fresh rock that exists in this location. And these are football-sized rock, and that stream has the power to move a rock of that size. So that's what we've got to design for from the standpoint of making sure that stream restoration design is going to have some resiliency to it. So that's one of the new buzzwords. You got to get these new sustainability, resiliency. So anyway, that just means we got to put some big rock in there. The project design components of stream restoration, floodplain, wetlands, riparian buffer enhancements, trails, trailheads, gateways. We have gateways located up along Cobbs Creek Parkway, and then street side green stormwater infrastructure. And natural stream channel design components. Here again you can see there's an indicator here of bank full, but you can see the amount of soil that's been washed. There's a steep slope in here that the stream, when the stream comes up, it erodes the lower portion of the slope, and so it's sloughed off a lot of that area. So again, stabilization of the outfalls and development of step pool, stormwater conveyances, and floodplain reconnection. Some of the approaches we're using, here's an A vein. Again, it just provides an extra step in there as you come down. And use these a lot on smaller streams. We definitely are going to have some larger cross veins in here. One of the things, again, looking at the current stream, the current stream is in a lot of cases 30 to 40 feet wide. When you go back, you look at the historic mapping and so forth, and even with the mills that were developed, the stream channel width was 15 to 20 feet. So it's increased in size twofold, and scoured and lowered in a lot of cases. And I suspect that in the development process, a lot of the rock that might have been in the stream channel was used in the development and pulled out of the stream. And that was standard practice. So your resistant material that might have been in the stream channel was used to build homes and farms and whatever. And so that's where your incision comes in, and the instability, and the stream can't get out of its banks. So in the assessment process, we evaluated and determined that it has pretty much done what it's going to do. It shouldn't get any worse. It has downcut, and it has widened to the point where it's not anticipated to go any further. So with that in mind, then the appropriate fixes are being evaluated. And again, the combined sewer overflows, you can see it's a scour, and so restoration of the outfalls themselves. This is the outfall below Market Street. And again, there's a large deep pool in here that there's some stabilization efforts that are proposed for that. Here you can see, and this is the Delaware County side, there's actually a manhole that surcharges. What happens is it's when you get the heavy rains and so forth, the water just surcharges and blows up through it'll pop the lids, except a lot of times they've got locking lids on them, or they'll weld them shut just to keep them from popping. But what happens is that water then rushes down the hillside, creates an erosional gully, and scours its way down through in instability. So in those cases where you can solve that problem, and most of these you can't because there's a tremendous amount of stormwater. So, but the intermediate fix is to incorporate the step pool systems for stability, and step those discharges down when they occur. And the reconnection of the of floodplain with the stream channel. Several areas, and again, you look back historically, these are the areas where a lot of the mills were located, and in some cases we're looking at those mill races to try to get the water out into the old mill race areas, the traces of those mill races, to get into these these floodplain wetland areas, to create these floodplain wetland areas. And again, the approach is to minimize the number of trees that we take. So that's one of the things, it's a balancing act. You've got to take a certain number of trees in order to make it economically feasible to get in there and do what you need to do. But so anyway, I think we've come to an agreement on which trees, with the ash borer, number of ash trees now have hit the to be removed list that previously were not allowed to be removed. So anyway, so that's the approach in some of these areas. All right, and then again, part of the project includes park and trail related green stormwater or green infrastructure alternatives and green stormwater infrastructure. So just a number of the features that we're looking at: the stormwater wetlands, step pools, bioswales and rain gardens, and interpretive educational signage. This is the access road going down into Cobbs Creek Community Environmental Education Center, and again, it provides a tremendous opportunity for that interpretive signage for stormwater, cultural heritage, a tremendous amount of culture and heritage within this small area. As typically there is, and as well as the watershed story, the restoration approach, and the combined sewer. So these are all envisioned for the project as it runs through completion. And some of the concepts. Now we're not building anything fancy like this, but this is an image that's pretty close to in concept what we're proposing to do. We have a number of areas where we're taking existing drainage hollow and we're going to restore the drainage to those areas with green stormwater infrastructure, bioswales, and so forth along Cobbs Creek Parkway. And then the overflow discharges from those, as well as the under drains, will discharge to stormwater step pools that'll convey it down the slope and into these rain garden or small little wetland pockets behind these bermed areas. So again, then bringing that down into the floodplain, connecting that with floodplain wetland systems. So again, you're taking that runoff, and when you pull it out of the combined sewer, you've got to safely convey it down the hill because you're dealing with large storms as well as the small storms. So again, that's the approach we're using to reconnect, to restore that watershed to how that may have happened at one point in the past, but that's the process. And again, some of the areas then you can see in terms of this is the typical section, the paved walkway along Cobbs Creek Parkway and Cobbs Creek Park to the west here. This is a small traffic island at Marshall Road. We're going to utilize that, put a small rain garden in that area to pick up some of the runoff from the intersection. And then we're going to, oh, there's already a green inlet there. Okay. So now we get out there and we see a number of inlets that haven't been maintained in a while, and when they're growing grass, you know they need to be maintained. So, but this is one that actually I think what we found is it was one of those between Parks and the city. Parks Department is actually responsible for maintaining some of the inlets, and because they're within the park and the city, and so this is a PennDOT highway, but the city maintains in the PennDOT right of way. So and that's why this one got lost in the shuffle. But anyway, so that one was cleaned out promptly, and what we're doing is going to take this small rain garden, put a true green inlet that's going to separate the sediment and leaf material and so forth, go into this small rain garden, come across the ramp road here into this, or actually a new inlet, take that down the hill into another rain garden in this location in this level area, and then bring that down. There's a rock line ditch that exists, so we're going to bring that rock line ditch back and restore that and provide some stabilization to that. So again, we're getting it out of the combined, getting that stormwater and runoff out of the combined sewer, and putting it back on the land and infiltrating it. And we did get some good infiltration results again at this location, but we will be installing the under drain. And these, here again, you've got a size that's available to you to build this rain garden. We've got trees that we can't take out. We've got a slope on this side, and we're really limited here. So the only choice we have in those cases, we've got volume requirements and the amount of runoff we're getting to this. The only choice we have at that point is to go deeper and excavate and put subsurface stone storage in with the under drain. So that's the process. These are not your typical front yard rain gardens. We do have some of those where we have small amounts of discharge. But for the most part, these rain gardens are fully designed like a detention basin with all the bells and whistles to function as one should that be required. And here you can see the subsurface infiltration storage tree trenches. These are examples from renderings provided by the city. They have some new renderings out on their website. You can take a look at those. I like the new ones, but I still like these from the standpoint of being able to see what's happening. I like this approach as well. And then the curb bump outs, curb extensions. We've got several locations on either side of the Cobbs Creek Community Education Center entrance where we're doing some curb extensions and curb bump outs. Some renderings of how they work, and again, these will also have under drains. We're putting low flow rock paths in them. One of the issues was we had some cobble-sized material design, and that's really all that's needed from an erosion standpoint. Like, no, can't do that. Somebody can pick that up and thought if it can be picked up and thrown, you can't have it. So we went to this size rock. So that's anyway. But and again, it's the learning curve, and you understand it. You have to understand the environment that you're working in, and there's a reason for that, and there's a safety reason, and so yeah, okay, it makes sense. So almost to the point though, if we go to this large of a rock, what's the cost associated with that, and is that the cost-effective thing to do? Well, it may end up being jettisoned in the end from a value engineering standpoint. So they're cheaper alternatives. So again, the street side swales and some of those options. Again, with the under drains, and you see some examples of those. One of the things that made it difficult, we really have a very narrow tree island here, so that's why we have the subsurface storage systems. The subsurface storage systems, infiltration storage systems, are to be located beneath that 10-foot wide paved access way. Paved walkway, and so this was one of the original concepts. But again, when you look back to how this was graded, everything drains from the park into Cobbs Creek Parkway for drainage purposes. But this would be the perfect place over here to be able to get that water out of the street and over into this location, except for the fact that the ground is 2 feet to 3 feet higher in a lot of cases. So we went a little bit further where the ground then starts to drop off towards the stream, and those are the areas for the most part we took advantage of our rain gardens, our larger rain gardens. And so we do have some cutting involved in piping to be able to get the water out. And that was one of the other things we wanted to use the trench drains in these locations. And there's some locations where it's possible, but maintenance doesn't like those. They're difficult to maintain, and so they don't prefer the tree trenches. Or the trench drains, but we are using a shallow inlet, and with that approach, then piping it back through. So you won't see along the street side. You'll see an inlet, and then you won't see anything, and then the rain gardens will be back over that little knob, so to speak, on the back side. So you have to be in the park to really see some of these things in a lot of cases, but. And here you can see, this is Market Street, side ramp there, the elevated rail station, SEPTA L, and this is a rendering of one of the rain gardens. It's a small rain garden, not a tremendous amount of infiltration on this. In fact, this is an area that the channel, the drainage way had actually did flow through that area at one point. The CSO, the outfall is down gradient about 50 feet. But this is a small system. It doesn't have a tremendous amount of runoff going to it, so it'll work fine. And we have a spillway built in, and that'll be safely conveyed down and back into the stream channel. It just gives you an idea. Now, the other thing going on here that we don't have shown is there's a gateway being developed in this location where we'll do some small berms in here, some landscaped berms and paver. We wanted to use pavers in here, but again, for maintenance reasons, they'd rather use the stamped asphalt. And that's, again, it's not a tremendous amount, and with the berms that we're creating, we'll have a system built there. We've actually got a system design where we're taking the runoff from that walkway in the paved area and drop it into a rock-filled trench and feed that back into the base material underneath. So we'll put a thicker base in this area, so it'll still infiltrate. And again, there's always a way of achieving the end result. It's just, you may have to take a little longer path in order to get there. But and we understand, the issue being that if you put pavers out there, you get a lot of grass growing up and through, and so you've got to treat them with herbicides and so forth. It's just a maintenance headache. So the asphalt or concrete is just easier to maintain. So anyway. So in streams and floodplains, really the goal is to rehabilitate the stream corridor ecosystem through the natural stream channel design, floodplain reconnection, and riparian buffer enhancement. And repair the existing infrastructure where you have those facilities. This is a parallel interceptor that's right in and right along the edge of the stream channel. And so there are restoration measures that are proposed in that area. But the reason that was encased in concrete was because it had scoured down and the channel had cut down to that parallel interceptor. And the goal to improve the utility of the park with the trailheads and gateways. We're creating about 5,000 feet, about a mile of new trail. And a significant amount of restoration on existing trails, or the paved trails and unpaved trails in a lot of cases within the park. There's the maintenance access trail that runs the length of the park, except for the area above Marshall Road. That's the piece that we're adding to tie the system together. Bring it across at a footbridge at the Cobbs Creek Community Environmental Education Center. And here you can see then the rain garden area. Again, the goal is to manage the street side stormwater runoff in local areas, the streets and walks and gateways. And there's just a little rendering of a rain garden, but that's what we're envisioning right in this area within the traffic island, and that'll feed down with the underdrain, and then that'll feed down to a larger rain garden. So it's kind of a sequential rain gardens. And in the end, the goal is to provide the long-term, wide-ranging social, economic, ecologic uplift, the triple bottom line. So, and this is, you can see, that's the bridge located within the park behind the Cobbs Creek Community Environmental Education Center. There's some Japanese knotweed and so forth. And again, there's just tremendous, and anytime you develop the riparian buffer restoration plan, I mean, that's a big part of it, is make sure you include management plan, herbicidal treatments, and yeah, you got to get in there and you got to use herbicides. There's just, some of this stuff is so nasty that you could sit there and pull it till you're blue in the face, and it'll still come back as vigorous as before. So. Yeah, exactly. So, and that's it, if there's any questions. Yes?
My name's Julie. I work for the Tacony Frankfurt Watershed Partnership.
Okay.
So we work on the Tacony Creek Park.
So you're working with Shandar?
On the
Okay.
other side of the city. So I was just curious to see what you had learned and what the water department had learned from the stream restoration in Tacony Creek Park that they've already done.
Quite honestly, I haven't really looked at that. I know there was a piece of restoration work done on that previously, and I haven't seen the most recent. Yeah. Generally, we look at each watershed, each stream independently because there's different controls and different approaches and so forth. But yeah, I'm not 100% sure of exactly what approaches they used on that.
So I know
But
they learned, they did a lot of modeling and everything, but not everything. Things don't always turn out. as it's
well,
all-
and that's anytime you're doing stream restoration, that is a huge component in this stuff. There has to be on-site oversight of the construction activities to ensure that it's going in properly.
I'm not saying it didn't go properly.
Well, and I was involved in the Fairmount Park Wissahickon Creek restoration work. And I was not involved in any of the construction of that. And so, and that's a big, and that, there again, that's one of those things that I think the water department realizes that there's certain things that they can do with their inspection forces and with their staff, and other things that the professionals need to be involved in a bigger part of the project, and particularly when it's going in the ground, because you can have the best piece of paper, the best plan, but if it's not properly implemented and if it's not appropriately and timely implemented and controlled, just like the rain gardens, if you don't control that water, and we've got sequences already set up for these rain gardens on this project where the contractor is required to start at the low end. In other words, don't even build the inlet until you've got the rain garden in and built, and then open that. Or if you're going to build it, plug that up, block that off. Don't let any flow into it. And the same thing is true of the stream work. But again, it's a learning curve. I think for the water department on the stream restoration, and I know in the past they've brought in professionals that have done a lot of that work, but again, if they're not involved in the construction, then that makes it difficult to properly implement what's on the plans. So that's just a general requirement in any of the stream restoration work. I mean, Joe, would you agree?
Absolutely.
Yeah, it's just you can't give this stuff to the regular. I mean, and I've been involved in.
That's not what I was saying.
No.
I was asking if there were lessons learned from that stream restoration and other stream restoration about the way systems work and
Oh,
what really
well,
works.
I've been. No, I'm not particularly familiar with that one, but I've done 25 miles of stream restoration work over the years. A lot of DOT projects, and that's how I know about the contractor issue, because it's typically a grading contractor who gets the DOT work, and he figures he can go out there and fix that stream and do whatever it needs, And so that's part of the challenge. Again, any agency is the challenge is making sure that the designs are properly implemented in the field.